Okay. Hello, everyone. My name is Girish, and this is Venu, my colleague. We're both principal engineers at Oracle. We'll be actually co-presenting this talk. I'll be talking for the first half of the session, and then the second half, actually, Venu will complete. Um, so this is a standard Harbor statement. I'm not going to read through it. So this is the agenda for today's talk. Basically, we're going to introduce ourselves and who we are, how we are leveraging OpenDaylight, and then Solaris network virtualization features to enforce SLAs end-to-end for Oracle multi-tenant aware enterprise applications. We'll also talk about some of the pain points that we faced while porting OpenDaylight on Solaris, and then what are our plans to contribute some of the stuff that we are working on top of OpenDaylight back to the community. We'll also, there's definitely certain gaps between traditional networking and application. So we'll be looking at how those gaps can be bridged and make the network application aware. We believe that application-aware SDN is a way forward as compared to platform-specific hypervisor-driven or network infrastructure-driven SDN. Application-aware SDN is the way forward. We'll be looking at how to enforce SLA for using Oracle Solaris and then OpenDaylight. So we are part of the Oracle Solaris networking team. So Oracle Database 12c is the latest generation of database from Oracle. It introduces a new multi-tenant architecture. We have a slide on how it does that later on. We'll talk to it. So to actually enforce SLA end-to-end, we really need three things, right? One is you need to identify the flow on at the edge, right? On the host where the application is running, you need to identify the flow. Having identified the flow, you need to determine what is the policy that applies to the flow. For us, we assume that the policy kind of is given to us through group-based policies or any other management framework at the top. So you have identified the flows, and then you have figured out what the policy is for the flow. Now you need to apply end-to-end these flows, right? So for that, we leverage ODL to kind of apply this flow at scale and then also in an automated manner. We are a silver member of ODL, and we have plans to support ODL in future release of Solaris on both x86 as well as the Spark platform. So the core tenant of cloud, if not the single tenant of cloud, is it's all about applications. Okay, let's admit the fact that one of the important reasons why enterprise service providers are all moving to the cloud is to run their applications. So what this means is that application developers who write those applications are increasingly deciding the value of the platform or the cloud. Application developers expect their application to be highly available. They expect the cloud to provide services such as load balancing as a service to make their application highly available. So they're expecting the cloud to provide isolation or security for the clients connecting into the application. So that the clients do not they do not see each other traffic. So they expect the cloud to kind of enforce SLA for the clients connecting to the application so that they do not step on each other's toes, right? And then they also expect cloud to provide some form of telemetry or monitoring, right? We have seen this bullet often in the last 2 days. So application monitoring and telemetry is a crucial thing for applications. So when we say telemetry, it is like mostly latency times for the clients connecting into the application. It's about throughput. It's about knowing whether SLA is being enforced on the clients connecting to the application. So it's very important for the application to know about all these things. And then an application represents a set of flows, and these flows need to be treated end-to-end. So when I say end-to-end, what we mean is from the point of origin, where the packet originates, all the way to the packet termination. Of course, we assume that both client and server are within the same management domain where the controller is. And then we have to address these flows on every entity in the network fabric. It does not matter if it's virtual or physical. Across all these entities, we need to treat the application flow. There are certain gaps that exist today between traditional networking and applications. the networking that we have today is largely unaware of application flows. So they're designed for speed and feed instead of kind of measuring the application flow completion times. So and then there's a lot of network unpredictability, as relate to configuration errors and then unplanned outages, right? So because of which, and then the networks are not self-healing. So we have, because of that, because of this unpredictability, you have application downtime. And then networks are mostly over-provisioned and often underutilized, which basically means that your CapEx is more. You're kind of preparing yourself for the worst, right? So you don't have a better sized network. You always over-provision things. And then applications are becoming more complex. They're becoming more multi-tenant aware. So which means that they themselves are trying to do the, they themselves are trying to provide multi-tenancy inside of their logic. So which means that just layer 2 to layer 4 support is no longer good enough. We need some kind of a deep packet inspection wherein we actually map layer 5 to layer 7 flows into these sets of layer 2 to layer 4 flows. I'll talk more about this later on. So no flows are created equally, which means that there are different types of flows with different characteristics, which means that they have to be handled differently in the network. And then, which also means that the distribution of flows and placement of flows becomes very important, right? Obviously, we need to bridge this gap that exists today between application and networking. So one of the ways to do that is to write this SDN application on top of open source SDN platform like OpenDaylight, and use the diverse southbound plugins that OpenDaylight support to kind of configure the flow in the network. And then use OpenFlow and service function chaining to program these flows and services in the cloud. And then you can offload for distributed processing, you can offload some of these services onto the edge, like when we say edge, mostly the host. And then on the host itself, you could, if you have a powerful NIC, you could offload some of these services onto the NIC itself so that the performance is better. So what we have here is basically applications expressing their intent. And the intent here is the SLA. And the SLA here could be, I want this much latency, minimum bandwidth share, priority. So they're expressing that intent directly to the controller through an SDN application. And this SDN application would then force relevant flows onto the network fabric. And then there's a feedback mechanism from the fabric back to the controller, right? If there is a port down or if there's a congestion through a path, the controller gets to know that. And then through that feedback loop, it reroutes the application flow through a different route, of course, ensuring there is an SLA. The controller also provides feedback back to the application, wherein it basically it goes back to the telemetry and the stats that I was talking about earlier. So the application knows that what are all the stats that relates to the clients connecting to the application. So that feedback is very important for the application to take further actions. Like we asserted before, application-driven SDN would be the most value that enterprise could get off through their SDN thing. So when applications can can express their intent, application here basically could be data warehouses, databases. They can express their intent to the network, and then network, since they're application aware, it can go ahead and implement those flows as necessary. Okay, hypervisor overlay. Just a slide just we want to talk about here is, so there's another form of SDN that we can deploy, which is hypervisor overlay, wherein the network virtualization is kind of built on top of the overlay. The overlay here could be VXLAN, NVGRE, and any such tunneling thing. So what that means is that the overlay just needs IP connectivity from the underlay. It doesn't. It kind of. It just needs a network fabric to provide the IP connectivity, and it decouples the virtual networking from the underlying network fabric, and it's very easy and rapid to deploy. What happens here is that between the edges, we create tunnels. The tunnels is created either in a mesh form or point to multi-point or point to point, and then the packet is kind of passed through these tunnels. So what this means is that the underlay or the network fabric just sees the encapsulated packet. It doesn't know what payload it's carrying. So it cannot provide differentiated services since it does not understand what the packet is carrying because it's encapsulated. So there are certain, I mean, of course, if for example, if we take VXLAN, if we map a VXLAN ID to each application flow, sure, that will give us a way to understand, based on the VXLAN ID that is mapped to, it knows what application it's actually shuttling, it's actually carrying. Of course, you cannot just scale with assigning VXLAN ID for each application flow. So there are some efforts in the industry where they actually are trying to carve out 24-bit VXLAN ID into small subsegments, and then try to make some sense out of the 24-bit VLAN ID, VXLAN ID. That again does not scale. There's a new standard called Geneve where through the Geneve header, you can express through new TLVs what is the payload that is encapsulated within the Geneve. So the elements in the network fabric can actually look into the Geneve header and then kind of make sense out of what's the payload that it's carrying, and then apply differential services based on the payload. But again, Geneve is not there yet, and then it's not implemented. It will take some time before all the network elements before all the network elements in the fabric implemented. The another thing with the overlay is that you now have two different thing, right? We have underlay, and then you have overlay on top of it, which basically means that you have two different management entities you have two different management software to manage the underlay and manage the overlay, and then you have two different provisioning policies to manage the underlay and overlay, and then again the SLAs. Right? There's a disconnect. You don't have a single window of pane to kind of do both, configure both your underlay and overlay. What we are basically saying is that to kind of support multi-tenant application flows for enterprise applications like Oracle DB, we need support from both underlay and overlay. Only then we can do true end-to-end SLA enforcement. So multi-tenant application. So let's talk about how applications has been evolving over time, right? So you have, in the case of a single tenant-aware application, if every tenant, what happens is that you have an instance of application running inside a virtual machine or a physical machine, and then you assign an IP address to that application, and you give that IP-based application to a tenant. So if there are hundreds of tenants, and if each tenant needs their application, then you would have 100 instances of application running in their own VM, and then you're going to assign each of that application to the respective tenant, right? But what's happening is that application is moving to a model where it's multi-tenant aware. It's becoming more smart, intelligent, complex, and then it provides multi-tenancy within the application itself. And for us, there are kind of two types of multi-tenant aware applications. So one is the port-based application, whereas the IP address is common for all the tenants. So all the tenants see the same IP address, but each tenant gets their own unique port. So that's how we do the demarcs between the tenants. In the second model, right, we have all of the tenants see the same IP address and the same port, and the application itself does the demarcs. Like it basically takes care of identifying which tenant is connecting to itself, which tenant is connecting to it, and then provide the necessary isolation and then SLA between those clients connecting to itself. In the first type of application here, the IP-based application, it's very easy to identify the flow because every tenant has a unique IP address to which it connects to get the service from that application. So it's easy to identify the application flow in the first case. Even in the second case, it's easy to identify because every tenant has a unique, even though it shares the same IP address, the port numbers are different for each tenant. So in that way, it's very easy to identify tenant flow in the second case. So the third case, what's happening is that all the clients, they see the same IP address and the same IP port. So your layer 4 based classification does not work now because all the applications are trying to connect at the same layer 4 IP address and port. So what we need is something which is layer 5 and above. We need some kind of form of a deep packet inspection to figure out what are all the clients connecting to the application, and then identify the flows based on the DPI. So what are the advantages of multi-aware enterprise applications? So obviously, you have very few instances of application running in a cloud, and each instance will serve some subset of tenants. So which means that economies of scale, right? And then since there are very few application instances running in the cloud, it means that it's easier to deploy and maintain. So which is economy of simplicity. And we have gotten obviously highest consolidation density. But the disadvantages are that now the application has to do the isolation between the tenants, right? It cannot no longer depend on the network to do the isolation. In addition to the network isolation, it has to do the isolation itself in the application itself. And then since several tenants are sharing the same application instance, you have a noisy neighbor problem where one tenant activity might affect other tenants' workload. So the application has to be careful about how it goes about resolving the noisy neighbor problem. And the third thing is, if the application dies, that means it's a downtime for a lot of tenants connecting to that application. So availability is another thing that application has to keep in mind. And then enforcement of SLA across the tenants becomes a challenge. So that's because now we have to use things like DPI to find out what are all the clients connecting to the tenant. So identifying tenant flows is no longer a L4 thing. It's something beyond L4, which is L5 to L7. So in that way, the enforcement, identifying the flows and enforcing SLA, it becomes a challenge. So this way, SDN, along with the OpenDaylight and Solaris network virtualization features that we have found a way to kind of address these challenges for cloud providers. So why should we worry about supporting multi-tenant application flows, right? So one of the crucial reason why we need to do that is to have better utilization of network resources and compute resources on the edge. So on the top, you have you have with no tenant flow awareness. What happens is that you do not have insights into per tenant flow. Since you don't have insights into per tenant flow, what's happening here is that it's very hard to troubleshoot the network because you don't have any idea about the existence of tenant flows. And then also you end up over-provisioning your network because you want all the traffic to go through all the network services in the firewall, like firewall and things of that kind, which also kind of increases the CPU utilization on the host because all the traffic is subjected to all the services in the network because you don't know what tenant needs what services. On the other hand, with the tenant-aware network, you actually identified the tenant flows, and then you know for each tenant flow that you have identified what is the flow profile in terms of SLA, like priority, bandwidth, latency, and then also in terms of what network services that tenant flow needs. So you only subject those tenant flow to the network services that flow needs. In that way, you consume less CPU cycles on the host, and then also with tenant flow awareness, you have insights into tenant flow statistics, which kind of provides you with an easy way to troubleshoot the network. Multi-tenant aware Oracle DB, right? So we're starting with Oracle database 12c version. The database is now multi-tenant aware. So before that, if anybody wanted an instance of Oracle DB, they had to, the admin had to install a DB in its own VM and then assign the entire DB to the application. So the thing is, even if they needed just few tables from the DB, you would have to install the entire DB and then assign it to the tenant. But with 12c, what's happening is that you have just a single instance of database running in the OS, and then that single instance we call it as container database, and then we carve out something called pluggable database from within this container database, and then assign this pluggable database to the tenants that need connection to. So that's the multi-tenant aware Oracle DB. I'll actually let Venu now continue from here on.
Thanks, Girish. So what I'm going to talk about is maybe reiterate a few things that Girish said, but in the context of the application that we are working on currently, which is the database applications. I'll also talk about the features that we are planning to leverage from OpenDaylight and Solaris, and also talk a little bit about towards the end where we are with this. So as Girish kind of mentioned it, you have traditionally what you can do is you can start a database application. You can start it on an IP address. You can start multiple instances of the database listening on, let's say, the same IP address, but different ports, or on different IP addresses, and maybe the same port. But what it allows you to do is it makes it very simple for you to isolate these different instances, right? So you have, you can isolate these instances based on just the IP address or the port number. So, and it becomes very simple for you to have like open flow rules based on either L3 classification or L4 classification, which is already there, and you can create rules based on open flow for these layer 3 or layer 4 and add them on the nodes where you get these, which is taken by this application, and you can kind of get an end-to-end SLA enforced for these flows, right? But the other way is what Girish was talking about is now the application itself is multi-tenanted. So what happens is it uses the same IP address, it uses the same port, but behind it, it kind of has multiple tenants. And the way clients usually connect to it is they have something in the payload that identifies which tenant in the backend it's going to connect to. So in this case, layer 4 is now going to be very helpful because pretty much all the tenants are going to classify to the same layer 4. And what we want to do is more layer 5 or layers more than layer 5 to layer 7 kind of classification in order to find out which is the backend tenant that we want to work with. There are a couple of ways you can do this. One would be, and I think this has been kind of mentioned in a few of the earlier sessions related to GVP. So you have a deep packet inspection, for example, wherein you look at the packet, you read the payload, you try to figure out which tenant it is, and you do the deep packet kind of classification at each node, and then apply some SLA that a policy database kind of assigns to it. And that way you can still get this end-to-end flow. But at that point, you're kind of doing this deep packet inspection at every place, and you're kind of looking at some impact at the performance, some performance impact. The other way to do this would be give some API or provide some API to the applications, right? So the applications themselves, if they are multi-tenant aware, they kind of provide you this information. They use the API to tell you that, OK, so this is the connection that I have. This is the client that is to the tenant. And you let the application tell you what flows you want to configure. This may or may not work depending on how much you can trust the application. So if the application runs in a very trusted kind of environment, you might want to provide the API and let the application tell you what the flows are. But in most cases, you want to run the applications and have some administrative kind of entity do this work for you. And Solaris actually supports APIs for applications, socket APIs for allowing applications to convey this message. But this is something that, depending on how the application is trusted, may or may not be used. So what we are looking at is, so layer 3 layer flow classification is not something that is good enough for us. So what we, and specifically with the database application, we use the resource manager that's associated with the application to tell us what kind of flows are being generated or created as a result of clients connecting to the tenants. Right? And once we have that, then what we do is we could do one of two things. We could take that, now we have this information between the client and the tenant, so we map that into a layer 4 flow, and then we use OpenFlow to kind of install that flow in all the nodes along the path. The other way would be what Girish said, we could use overlays. Say, for example, we could use Geneve tunnels to carry extension headers that carry the application ID. So on the host, what you do is when a client connects to a tenant, you get the application ID at the edge, and then use that in the Geneve header, and then let the packet kind of go through the different nodes. But then you're assuming that all the nodes in between can interpret the header, get the information, and provide the SLA that's associated with that flow. as far as policies are concerned, we are not going to talk about it in detail because we're assuming that there is already some other component, either to ODL, OpenStack, that allows us to configure these policies based on clients or tenants for that matter. So this kind of illustrates what I was talking about. So there is let's assume there's a VM on the left that kind of wants to talk to a VM on the right that wants to talk to a tenant that's on the right. So what we want to do is on the host on the left, we want to be able to identify the tenant. So you get the connection. There's a listener, database listener. What it's going to do is it's going to say, it's going to map that to one of the tenants, and it's going to now create this a flow, which is your regular 5-tuple kind of a flow, and then it uses an application that configures that uses REST APIs to configure the flow on the controller. And that flow will be mapped to any policies that you have already configured through some other means. And that flow that open flow rule is now installed on the host, on the vSwitch on the host, and throughout the network fabric, assuming all of them are in the same kind of data center or cloud, and on the end host as well. What happens now is when there is any packet coming in for that connection from the client to the tenant, it goes through all these different nodes, matching the flow that you have already installed, and it uses SLA that's been configured for that particular flow. What this kind of assumes is that application is intelligent enough to kind of trace the path for you for that flow, or for that matter, actually configure that path for you for that flow. And then you implement or enforce the SLAs on each of these nodes. The SLAs in this case could be pretty much anything. It could be just a priority, for example, or it could be restricting the bandwidth or providing a share of the bandwidth for the flow. What we could, when I said priority, and in this case, what we're talking about is it goes through all these nodes that are probably under the same domain, management domain. But what if the packet kind of goes to an external network, right? What we can do is we can still use the existing mechanism to tag the packet using a priority, say, for example, DSCP, which kind of most of the nodes already understand. And then we'll assume that the nodes now can translate that priority into some kind of behavior that can be given for that packet in the flows. So within this network, if you can actually maybe have a lot more granularity in the form of what kind of SLAs you can support using open flow rules. And externally, if you want to go, you can probably use DSCP. That's what we are kind of looking at right now. Once you have flows that map to a tenant, what this also allows you to do is the services now are kind of per tenant, right? So it allows you to monitor what's happening on a per tenant basis. And it allows you to kind of correlate what's happening on a per tenant basis and given the network state. What it also allows us to do is kind of tie it into some of the what was called the reactive management kind of framework, and allows us to see whether things are going on fine, and if things are not going on based on the SLA, for example, that you have configured for that flow, then you could either do some sort of issue an alert, for example, or you could try to do some self-healing and try to do some corrective actions. So it allows us to tie it into any reactive management kind of a framework. On Solaris, we have a fault management framework, and we can kind of just hook this into that. And it also allows us to provide end-to-end kind of flow tracing. It allows us to kind of trace these flows on a per node basis, which it traverses, and we can kind of get some added statistics based on that as well. The other aspect, so the thing that I was talking about earlier mostly uses the SDN controller, the OpenFlow plugin, the OpenFlow REST APIs, and the OpenFlow kind of southbound plugin. The other thing that we want to leverage of, excuse me, ODL is the service function chaining part of it, right? So any application typically it goes through multiple services, right? And these are some of the services that I just generically mentioned. But what we want to do is we want to use ODL's framework, SFC framework, to stitch services for tenants. And we want to push it to the edge so that we could optimize some of the services that we provide for the applications or for applications, basically. And what I think, what we want to do is we believe that if you want to do some kind of an L5 to L7 kind of classification, it's much more effectively done on the host or on the edge. So pushing these SFC services on the edge kind of makes it much more effective. And what it also allows us to do is now, if you have implemented all the services, say, on the same host, it allows us to kind of collapse services if possible, and also offload some of these services either on the hardware itself for performance reasons, or maybe in the kernel rather than just send it to a VM and do it on in a VM. So it allows us to do a few things if you offload some of these services to the edge in terms of effectiveness and performance. And it also allows us to dynamically kind of program these chains. I mean, for example, if there is a tenant, a client is connected to a tenant, and we want it to, and we have assigned a bandwidth for that client, for that connection. If it goes beyond the bandwidth, then we can say, okay, now let's take this maybe to some other service and do some additional kind of processing to see whether it can use the additional bandwidth, or whether we need to kind of restrict it based on the bandwidth that's configured. So it allows us to program some of these services on the edge based on how we can, based on the mapping that we can do to a tenant. So the next few slides I'm just going to go over will be some features in Solaris that we leverage to achieve this, and also I'll also talk a little bit about where we are with ODL and Solaris on this one. So Solaris in general kind of provides a lot of functionality that allows us to work very well in a cloud or data center. And these are some of the functions that I just have listed here in terms of security, performance, and the ability to support application-based SDN. I'm not going to go in detail on this one, but this is mostly for reference. And I don't expect you to read this either, but this kind of talks about the networking functions that Solaris provides, and has provided for some time now, right from the last release onwards. That kind of makes it very relevant to being in a virtualized kind of setup, and also work with SDN specifically. So in terms of network virtualization, we support like virtual NICs, virtual switching, and wherever possible, hardware-assisted virtual switching, and also protocols like DCP, EVP, PVLANs, VXLAN, so on and so forth. Resource control, Solaris supports like QoS limiting, bandwidth specifically, and also tying CPUs to VMs or virtual NICs. Solaris also, and the reason why we are talking about SFC is on the edges, because Solaris already supports built-in network services like firewalls, load balancers, VRRP bridging, so on and so forth. And we also integrate well with Neutron, and Girish can maybe talk a little bit about.
Sure. Actually, we integrated OpenStack into Solaris natively. It's not a separate distribution. If you install Solaris, OpenStack is part of the OS. So you just need to just do pkg install OpenStack, and it will bring along all the dependencies that is needed to run OpenStack. We integrate OpenStack Juno into Solaris. And the Neutron implementation is something called Elastic Virtual Switch, which is a network virtualization feature which allows to interconnect, which implements the Neutron API, and then which interconnects virtual machines that are, which is zones for us. Yeah. So.
Okay, so where we are right now, I mean currently, right? So we plan to support Open vSwitch on Solaris in order to leverage the OpenFlow and OVSDB protocols. We have run ODL on Solaris. We found a few issues, primarily with level DB not working on Solaris. So we kind of ported it to Solaris and are working with working with the community to get it integrated into into upstream. We have some issues with Node.js not being supported on Spark, but it's mostly a compile time issue and not specifically a runtime issue. There are some of the issues that we kind of came across when we were working with ODL was, I think this was mentioned in a session yesterday about using ODL from the community rather than forking ODL. So it's mainly around the licensing requirements. What we have in Oracle Solaris, we have to kind of go through all the licenses that are on each of these components that is used to build ODL and kind of make sure that we are fine with it. And we, thankfully, we got a lot of help from the community to identify what kind of licenses are there in the ODL components currently. As far as testing is concerned, from what we understand, we would like to leverage the test frameworks in the community as much as possible, but I do believe that there are some kind of gaps in that area. For example, there might be some tools that we don't support on Solaris currently, and that kind of makes us makes it a little difficult for us to participate in the testing frameworks to leverage at least the test suite and test cases that are already there in the community. So for now, we have to kind of write some of these test cases on our own and test it on Solaris. What we can do going forwards, so we'll be very glad if folks reach out to us and participate in the Platinum program, which would give them exposure to the OpenDaylight or Open vSwitch support on Solaris. We'd also like to work with the community to make sure that some of the issues that we have seen so far in terms of ODL working on Solaris x86 or Spark, some of the issues that we ran into, we don't kind of run into in the future. So that we do realize that we would have to work with the community in order to make that happen. For example, we could provide some of these build infrastructure, Solaris Spark, for example, so that the build and the testing kind of involves the Solaris or Oracle Solaris x86 Spark as well, so that we don't have to constantly kind of monitor whether something is broken on Solaris x86 or Spark for that matter. So I think that is pretty much that we had, and I think we have quite some time here for questions if folks have any questions. No questions? Okay.
Rob?
So when will this be available in Solaris?
We cannot actually give you an exact release, but it is planned for one of the future releases.
So a year, 2 years, 10 years?
I think it should be, well, if roughly we are talking about maybe a year and a half.
Yeah, definitely not 10 years. So.
So we are hoping that that is something that should be available maybe in the next like 3 to 4 months kind of a time frame, or maybe 4 to 5, somewhere around that time frame, 4 to 6 months.
Is that free? You can become a beta customer, or do you have to buy a service contract?
Yeah, I think you need to kind of sign some sort of NDA and then be part of the program, I guess. So probably we can talk offline.
Any other questions? Okay. So if there are no other questions, I think we have probably done a little early.
Yeah.
Thank you so much for joining. Oh,
Sorry, go ahead.
Sure.
So that inclusion of Open vSwitch, so is it possible to be able to swap out that forget what you call your
Elastic Virtual Switch?
Elastic Virtual Switch.
Is it possible to swap that out for the Open vSwitch or another product? You want to do that?
Yeah. So the current OpenStack Neutron plugin that we have is exclusively, it's a monolithic EVS plugin, which exclusively works with the EVS. But we are also trying to get OVS ML2 plugin ported into Solaris, and so that it just directly talk to OVS. So if you need heterogeneity in your cloud, then OVS ML2 talking to Solaris OVS, and then Oracle Enterprise Linux OVS or any other OVS would be the path forward.
That's smart.
Yeah. And then if you just have a homogeneous thing, then EVS, if you have just running Solaris in your cloud, then EVS would be the. Cool.
Okay, folks, thank you so much for joining.
Yeah, thank you.
Thank you.